Ladies and gentlemen, today I will be sharing with you what you need to know about the scalable proof-of-stake blockchain Algorand and a recently launched feature that could be a powerful tool for garnering adoption of Algorand in the years to come. Now, over the last couple of years, many people have asked me to do an explainer related to Algorand, and it was high time that I started that process. So this is the first of two videos that will do this. But Algorand is at its core a highly scalable blockchain network with smart contract capabilities powered by its beautifully designed pure proof-of-stake consensus mechanism. The technological underpinnings of Algorand are the brainchild of a rather legendary computer scientist and professor at MIT, Silvio Micali, who's credited with countless pieces of significant research and invention on topics like randomness, or VRF, consensus, zero-knowledge proofs, etc. Needless to say, Micali and the talented team behind Algorand have the pedigree and the knowledge needed to build a quality blockchain protocol, and they have done so. Candidly, Algorand has not gotten the recognition it deserves for most of its existence, to be quite fair about it. Now, at the heart of the Algorand network, you have the pure proof-of-stake consensus mechanism that provides fast finality of transactions, high transaction throughput, and ample security for those who transact on the Algorand blockchain. Algorand's consensus protocol uses a verifiable random function, or VRF, to pseudo-randomly assign users to voting committees that are responsible for the various phases of consummating a block of transactions on the Algorand network in a given slot or cycle of consensus. While the voting committee's user voting weight and probability of selection is still determined by how much algo, the native cryptocurrency that they have in their account, the random assignment through VRF provides sort of a check and balance to this parameter of wealth. In general, this process is broken down into three main phases. You have block proposal, a soft vote, and then a certified vote. And throughout the consensus process, randomly sized and populated committees are selected using that aforementioned verifiable random function. And each account can easily be proven a legitimate voting committee member by verifying a VRF proof. And this process happens in a cycle for every block at high speed, producing a 4.5-second block time on Algorand with instant finality and around 1,000 transactions per second. At the time of recording, at least, this will change over time. The net result for the end user is a proof-of-stake protocol that does not require access to one's spending keys or custody of one's assets, and that produces a scalable transaction throughput and low-fee blockchain with adequate security. Of course, those who have been in the crypto space for even a short amount of time will realize that simply providing a scalable layer 1 blockchain is not enough to make a splash in the crypto space. Decentralized applications, or dApps, are what gives a blockchain utility for investors, users, and builders. And Algorand offers its own smart contract execution environment with which developers can build a variety of decentralized applications in areas like DeFi, and even bridging into traditional finance. The Algorand Virtual Machine, or AVM, provides both mechanisms for building smart contracts that live on the blockchain and can be called by any node in the Algorand blockchain, as well as support for stateless signature schemes that allow for one to encode logic that enforces conditions on how transactions are signed. Very useful, and I will not go incredibly deep into the details of AVM, but what you need to know is that it offers a highly programmable and flexible platform on which developers can build dApps using a widely adopted programming language in Python. In tandem with Algorand's digital asset standards, dubbed Algorand Standard Assets, or ASA, AVM smart contracts and smart signatures are a powerful tool for builders to create scalable decentralized applications with a pretty wide set of functionalities. Now, in the intro, I alluded to a sort of secret weapon or new feature of sorts for Algorand, one that will very likely spur on adoption of the network, and that feature is called Algorand State Proofs. And Algorand State Proofs is a feature that's coming to mainnet in 2020, and it's already been announced and already been seen in testing at Algorand's November 2021 Decipher event. In a nutshell, Algorand State Proofs provides the ability for entities external to Algorand to cryptographically verify events and state on the Algorand blockchain via a signed proof. And by the way, when I say state, quote unquote, I mean data that's stored on the blockchain, things like user balances of tokens or data stored via smart contracts, etc. A state proof in this context consists of a bundle of signatures that attest to a certain piece of state or an event on the blockchain. Effectively, a state proof is a signed certificate of attestation of the state and existence of some type of data, or some data itself, backed up by the trust dimensions and security guarantees of the Algorand network itself. At face value, this might not seem like a big deal, but it is the application of these state proofs that make it very powerful. First of all, with a state proof, interoperability use cases become a lot more viable because other blockchains that wish to connect to Algorand in DeFi contexts, or even banks that wish to reconcile transactions that occur on Algorand, can easily verify the information on the blockchain with signatures intact. For example, imagine an Ethereum decentralized exchange that has fed state proofs from Algorand to track the movement of assets on the Algorand network. This is also useful for external applications and utilities like wallets that might not always have direct or consistent access to a node on Algorand, whereby the wallet uses state proofs to get in sync with the blockchain despite intermittent loss of direct access. This could even be used to improve node synchronization processes and other ancillary tasks in the Algorand ecosystem tech stack, if my thinking is correct. Imagine, though, a world where Algorand becomes a sort of root trust anchor in the certain multi-chain future that we are heading to, and one that I've talked about all the time. Algorand state proofs can be a means to this end and a great tool. It gives an entire external world the ability to securely and confidently trust attestations of events and state on the Algorand network. And the final note I want to make on this front is that this state proofs technology is also a means to a much different but much more important end, and that is quantum safety. Now, to simplify this and to keep it brief, super powerful quantum computers pose a threat to modern cryptography suites that underpin the web, blockchains, and more. And quantum safe cryptography is going to be very important in the coming years. Because the security of a blockchain network is derived from cryptography and these cryptographic primitives involved in signing and hashing, etc., there's a need for post-quantum standards to ensure the long-term finality and security of blockchain transactions. And so these state proofs not only use quantum resilient cryptography standards, but they provide a way to stamp the state or history of the Algorand blockchain so it can persist even in a post-quantum environment. And this may not seem significant now, but as we track increasingly quickly towards viable quantum computers, this is going to get increasingly more important as time goes on. Now, with your newfound understanding of some of the powerful technology that Algorand offers as a backdrop, and there will be a deeper dive into Algorand and its history and all the little underpinnings and how the consensus process works, I do want to also double down and mention that Algorand is really working on growth in the years to come, with over $1 billion in funding available for developers and builders. And this funding is available in the form of grants, incubators, and other programs for those building in the Algorand space to get resources to build with. This is a critical part of the growth of Algorand, so I do tip my hat to the Algorand Foundation, Borderless Capital, Arrington Capital, Skybridge, and the other accelerators for making this happen for the Algorand community. In tandem with this opportunity for funding, developers looking to build on Algorand can also head over to the, frankly, fantastic developer documentation I've been perusing for the last several months and get started. And I will say from experience that the Algorand developer relations team is very responsive on Discord for questions that might arise and giving help to people who are working in the space. So I'll leave links to both the docs and the Algorand Discord in the description if you're interested. If you want to learn more about Algorand, I will leave further reading material in the description as well for you to peruse at your leisure, and I would also encourage you to subscribe to the channel for more explainers like this and a follow-up video on Algorand that's coming really soon. There's plenty more to come here. I want to thank you so much for watching, and until next time, cheers.